Happy Saturday, everyone. Today we are going back to 2011 for Sarah and Deblina's episode on Rosalind Franklin and her research into the structure of DNA and why, for a long time, that work went unrecognized.
Enjoy! Welcome to Stuff You Missed in History Class, a production of iHeartRadio's How Stuff Works.
Hello and welcome to the podcast. I'm Deblina Chakraborty.
And I'm Sarah Dowdy.
And even if you're not a science person at all, you probably know something about DNA, that stuff in our cells that carries the cell's genetic information and basically determines all of our individual hereditary characteristics, hair color, eye color, the whole deal. So if you watch TV, you probably know at least that much. But most of us probably have at least touched on the subject in high school too, or will touch on it in high school, not to rule out our younger listeners. And we can recognize what DNA looks like, that unmistakable double helix that looks like a twisting ladder or a spiral staircase.
I remember actually modeling it in middle school with pipe cleaners, so maybe some of our younger listeners already know.
Well, the people credited in most high school, middle school textbooks, at least when I was in school, which admittedly was a while ago, the people credited with discovering the structure of DNA are James Watson and Francis Crick. That's one of those associations that kind of has stuck in my mind over the years. You know, it's like Darwin and natural selection and Watson and Crick and DNA. And after all, they, along with Maurice Wilkins, received the Nobel Prize in medicine for this discovery in 1962. So it makes sense that their names would be most associated with this accomplishment. But especially in recent years, some more attention has been paid to someone else who may deserve a great deal of the credit for the discovery of DNA structure, and that's a British physical chemist named Rosalind Franklin.
So Franklin's involvement in this DNA discovery has caused quite a bit of controversy in the science world for a number of reasons. So number one, it's without question that her research played a really big role in helping suss out DNA's structure. But because she died 4 years before Watson, Crick, and Wilkins even received the Nobel Prize, the prize only honors living scientists. So
Except for this year.
Except for this year.
Yeah, except for this year, there was Ralph Steinman. Did you hear about that?
I did.
He won the prize for medicine, and I think the announcement was made 3 days after his death.
So they went ahead and
let it stand because they had made the decision before they even knew he was dead. So
well, then up until this year.
Until then.
They are more associated with it because they won the award for it.
In Watson and Crick's famous 1953 paper detailing their discoveries in the journal Nature, they only gave Franklin the tiniest credit. And so consequently, she's virtually or has been virtually unknown for this accomplishment.
So that's the second reason. And then the third is in his 1968 book chronicling the discovery called The Double Helix, appropriately enough, Watson noted the role Franklin's research played and also revealed that it played a role without Franklin's knowledge. That's a pretty big one there.
Sketchy. So you can see where the controversy comes in. This revelation raised a number of questions. For instance, did Watson and Crick steal Franklin's research? And if they didn't, would she have figured it out? Would she have figured out DNA structure on her own? So we're going to address these questions and more as we take a look at what really went down in England in 1953 when this particular discovery was made. But first, we're going to take a look at another relevant question here. Who was Rosalind Franklin, really?
So in Watson's book, The Double Helix, he kind of dissed Franklin a little bit, basically depicted her as stubborn and hard to work with and unfeminine. But other people who knew her really characterized her in a different way. What we do know, personality aside, is that she had a passion for science from the very start. She was born Rosalind Elsie Franklin in London, England on July 25th, 1920. And of course, most girls around that time were expected to have very few goals outside of becoming successful wives and mothers. But Franklin's parents, Ellis Franklin and Muriel Whaley Franklin, were more progressive and really encouraged their daughter academically. They even enrolled young Franklin in the St. Paul's School for Girls, which was one of the few schools at the time that offered physics and chemistry lessons to female students.
And Franklin really excelled in these courses, and she decided by the age of 15 that she really wanted a career in science, even though her parents wanted her to pursue social work instead. So she enrolled at Newnham College at the University of Cambridge in 1938 and was one of only 500 women in a class of more than 5,000. She earned a bachelor's degree in natural sciences with a specialty in physical chemistry in 1941. And we should stop here for just one second when we have noted her scientific achievements, or her initial ones, to give a little disclaimer and say that we're not scientists here and do not have degrees in science. So we're going to be kind of vague about some of the concepts that we explain here, and hopefully listeners will forgive us for that.
Well, and part of it, too, is to focus on the people involved.
Yeah, and the story involved, because sometimes if you get too bogged down in the other details, you miss out on some of them.
Y'all can easily find out scientific details on this. So continuing on with Franklin's life, after earning her bachelor's degree, she got a research scholarship in the study of gas phase chromatography with the chemist Ronald G.W. Norrish, who was a future Nobel Prize winner himself. But the progression of World War II and the fact that Franklin found Norrish kind of difficult to work with changed her course of study a little bit. According to Encyclopedia Britannica, she served as an air raid warden in London and also left her job with Norrish in 1942 to do war-related work as a researcher with the British Coal Utilization Research Association. That's kind of a mouthful, in southern England. And while she was there, she worked on studying the physical chemistry of carbon and coal, and the work she did ultimately led to some really enlightening ideas about coal structure. So a little bit of foreshadowing almost of work she'd do later.
She also learned the basics of molecular biology and crystallography while she was there, and her work earned her a PhD from Cambridge in 1945. She also authored 5 coal-related papers that are still cited today before 1949. According to an article by Lynn Osman Elkin in Physics Today, Franklin's papers, quote, changed the way physical chemists view the microstructure of coals and related substances.
So Franklin's work, in addition to getting some praise by current scientists, got her another job offer. In 1947, she moved to Paris to work at the Central Laboratory of Chemical Services, where under Jacques Mering, she learned to use a technique called X-ray diffraction when working with crystalline matter like coal. And just to give you a basic rundown of that, X-ray diffraction allows scientists to see the three-dimensional structures of molecules by blasting a crystal with X-ray. So the rays bounce off the atoms and diffract in different directions, and the escaping X-rays expose photographic film to create this kind of shadow of the molecule. And then scientists interpret the photo to reveal the molecule shape and its measurements, and allows them to look at it on a closer level. So Franklin used these techniques to discover a lot of details about the structure of carbon, even as it's heated and changes into other forms. So not just carbon in a static state, but transforming.
So Franklin was doing good work in Paris, and by most accounts, the 3 years or so that she was there were the happiest ones of her life. According to that Physics Today article by Elkin, Franklin had friends in her Paris lab and would hang out with them, sometimes do things like going hiking, and she became fluent in French and skilled in French cooking and just became really comfortable with her life there. It provides a really stark contrast for the next period of her life that we're going to talk about, the one in which DNA takes center stage. So now that I've set that up, I should go right in telling you all about it, I guess. So even though Franklin was happy in Paris, she got lured away by the offer of a research fellowship from Sir John T. Randall's Medical Research Council at King's College in London, and also the chance to work on one of the major scientific challenges of the moment, figuring out the structure and function of DNA. And Randall especially wanted Franklin to use the X-ray diffraction techniques that she'd mastered to produce diffraction pictures of DNA. But when Randall brought her in, Maurice Wilkins, a British biophysicist who'd been working in the same lab on the same project, was not happy to have her around. They didn't work well together and ended up disliking each other the entire time they worked together, pretty much right off the bat.
Yeah, and biographers have had a hard time figuring out why exactly Wilkins and Franklin didn't get along. Some think it's because he happened to be away traveling when Franklin got hired and started her job. So when he returned, Wilkins originally thought that she was working for him. Another point of contention is that Franklin, of course, had other ideas. She knew she wasn't going to be working for Wilkins. She assumed that she'd be working independently.
Yeah, she thought she was the boss of the project.
Exactly. So they both had conflicting ideas of who is boss. And she also had more experience with X-ray diffraction techniques, of course. I mean, that was why she was brought in the first place. And kind of forged ahead and took the lead with that. So Wilkins might have felt that his project was being taken away from him to some degree.
Franklin was also said to have a very serious, direct, and even argumentative style when it came to her work. And Wilkins did not take well to this. It's said that when she argued with him, he would really just shut down and kind of give her the silent treatment. He just wouldn't respond.
So they didn't have a functioning relationship.
Not at all.
So this rivalry is probably one of the main reasons that Franklin was so unhappy at King's College. And some have theorized that her unhappiness was also related to sexism toward female employees at King, saying that women weren't even allowed to eat lunch in the same dining rooms as men. But there's been some new ideas on that theory.
Yeah, I mean, you see that mentioned a lot, the whole lunch thing, that they were excluded somehow from eating lunch with their fellow scientists. But researchers such as Brenda Maddox, a Franklin biographer, have found in recent years that the working environment at King's College was actually more welcoming to female scientists than some have portrayed it to be. They actually did get to eat lunch in the same room. So Maddox thinks that Franklin's class and religion, she was Jewish and came from a wealthy family, may have actually made her feel more out of place than anything else. And though her demeanor in the lab was serious and sometimes abrasive, many of her colleagues remember her as being witty, bright, interesting, even fun.
In the lab, though, of course, Franklin was all business, and her rivalry with Wilkins didn't stop her from investigating DNA fibers at all. Pretty soon after she got to King's College, Franklin, working along with a student named Raymond Gosling, managed to get some preliminary diffraction images of a DNA molecule as it transformed from its dry crystalline form, which she called the A form, to the wet B form through an increase in relative humidity. And from this observation, Franklin determined that the phosphate groups that make up the backbone of DNA run along the outside of the molecule, one of her first milestones in determining the structure of DNA, because previously people had thought that they were on the inside.
Yes, and that the bases were on the outside. So this was kind of a major discovery for her. So in November of 1951, Franklin gave a talk in London about her latest findings, and American scientist James Watson was in attendance. Watson and then graduate student Francis Crick had also been working on figuring out DNA structure at another Medical Research Council unit at Cavendish Laboratory in Cambridge. But they weren't doing it by experimenting and collecting data. They were doing it through deduction and model building. So when Watson heard Franklin's talk, he didn't really take notes and he misinterpreted her results, but still relayed what he'd heard, incorrectly of course, to Crick, and they used that info to slap together a quick model with the sugar phosphate backbone on the inside. So about a week after the talk, Franklin and Wilkins visited Cambridge to check out Watson and Crick's model. As soon as Franklin saw it, she immediately realized their mistake and pointed out that the phosphate group should be on the outside. And this experience probably just confirmed for Franklin that careful and diligent experimentation was much more valuable than making intuitive leaps.
Rash model building. So
Yes.
After this mess up, Watson and Crick were actually told to refrain from DNA modeling for a while, like just take a chill
Focus
pill,
on
boys.
proteins. Yeah.
Exactly. So Franklin continued to approach her DNA experiments with that methodical, research-based manner, and they helped her determine DNA's density, its unit cell size, water content, interphosphate distances, and other really precise kind of calculations. And the one point she got a little bit tied up on, though, was DNA's helical shape. So some scientists, including her rival Wilkins, were convinced that DNA's shape was helical before they had any proof of it. But as we kind of mentioned, that wasn't Franklin's style at all. She needed to prove it through experimentation. She needed to observe it.
Yeah, this was tough, though, partly because she was so methodical in her research. She started out by focusing on the diffraction image of DNA's crystalline A form, in which it was much harder to discern that helical shape. So at one point, after obtaining some data from the A form, which suggested that DNA was non-helical, she actually created this Death of the Helix funeral invitation in July 1952. And some kind of see this as evidence that Franklin was on the wrong track in figuring out DNA structure. Others, including Elkin in her Physics Today article, note that it was a joke, mainly directed at Wilkins. And
I think you ought to read a little bit of it.
Yeah, we have a copy of this funeral invitation, and it's quite interesting. It says...
Written by hand, too.
Written by hand. It says, "It is with great regret that we have to announce the death on Friday, 18th July, 1952 of DNA helix, parentheses, crystalline. Death followed a protracted illness which an intensive course of injections has failed to relieve. A memorial service will be held next Monday or Tuesday. It is hoped that Dr. M.H.F. Wilkins will speak in memory of the late Helix." And then it's signed with her name.
I mean, I think this certainly proves that she had a sense of humor.
Yes, for sure.
So Franklin's personal notebooks, as well as information provided by Raymond Gosling, indicated that she believed the B form to be helical, but before she could get all of her conclusions together, something truly unexpected happened. Wilkins and Watson had kept in touch and actually became pretty close after that meeting where they viewed Watson and Crick's incorrect model. And in January of 1953, Watson came to King's College to visit with Wilkins, and Wilkins showed him the now famous diffraction photo of the B form of DNA that Franklin had taken in May of 1952. And that photo, which was known as Photo 51, was revolutionary because it was the best photo of its kind at the time. And Franklin took the photo looking down on the DNA molecule, and what appeared was this very distinct X pattern, which was, of course, clear evidence that the molecule was helical.
So Franklin had apparently put the photo in a drawer while she focused on the A form, and while it was in that drawer, Wilkins was able to access it. Some sources even suggest that he'd been making copies of all of her research to keep her from getting ahead of him in a way. And when he showed Watson Photo 51, though, Watson and Crick were the ones who instantly pulled ahead. In The Double Helix, Watson describes his reaction to the photo. He says, quote, "The instant I saw the picture, my mouth fell open and my pulse began to race. The pattern was unbelievably simpler than those obtained previously, and Maurice told me he was now quite convinced that she, meaning Franklin, was correct." And Watson immediately rushed back to Cambridge to tell Crick what he'd seen. And meanwhile, Crick had obtained a copy of a 1952 Medical Research Council report, which contained a section including some of Franklin's data. So with these two sources of information, they were able to start creating a correct model within about a week's time.
And then in April of 1953, they published one of the best-known scientific papers of the century called A Structure for Deoxyribose Nucleic Acid in the journal Nature. And in it, they described their double helix DNA molecular model with its complementary double strands forming the sides of a twisting ladder and bases forming the rungs of that ladder. And Franklin and Gosling revised a draft of their own to appear along with Watson and Crick's, but partly because of the placement it received in the journal, it seemed to just support Watson and Crick's findings, even though her research was a huge, if not the main reason why their paper existed in the first place.
Franklin only received one line of acknowledgement in that 1953 Watson and Crick paper. In his Nobel Prize acceptance speech in 1962, Wilkins only mentioned her after thanking 13 other colleagues by name. Watson and Crick didn't mention her at all.
So this is where the controversy begins, and a lot of people wonder whether Franklin would have reached the same conclusions as Watson and Crick did on her own eventually. And a lot of people think that, yes, she would have. For one thing, unpublished drafts of her paper and information in her notes suggest that she was close to getting the same results. And Crick even said in 1974 that she was only 2 steps away from the solution.
In an excerpt from his memoir, Avoid Boring People, that was published in Technology Review a few years ago, Watson said, quote, "Rosalind Franklin would have seen the double helix first had she seen fit to enter the model building race and been better able to interact with other scientists." He also told Scientific American, quote, "We're very famous because DNA is very famous. If Rosalind had talked to Francis starting in 1951, shared her data with him, she would have solved that structure, and then she would have been the famous one."
They did give her credit here and there, though. Of course, there was Watson's book that we mentioned, The Double Helix, which reveals everything. But according to a 2003 article in Wilson Quarterly, as soon as 1954, Crick had stated, quote, "Without Franklin's data, the formulation of our structure would have been most unlikely, if not impossible."
Some take this as evidence that Franklin must have known about the fact that Watson saw Photo 51, but others think that knowing her personality and how feisty she could be, if she'd known that they'd seen it without her permission, she would have been very angry. Ultimately, Franklin's biographer Maddox says there's no real evidence that she knew what research of hers Watson and Crick had obtained, so that part's still kind of a mystery.
What we really know, though, is that Franklin didn't seem too troubled about losing the race to discover the structure of DNA, probably because she didn't consider herself in that race in the first place. For her, it had all been about discovering the truth. So Franklin was, of course, eager to get out of King's College, considering how unhappy she was there. And she did that by the spring of 1953, around the same time that the Nature article was published. She ended up taking a position working in the crystallography laboratory at Birkbeck College in London. And it's there that she began to work primarily on investigating the structure of the tobacco mosaic virus. She published 17 papers while she was there, including 4 in Nature, and she was much happier professionally. I mean, I think the fact that she published 17 papers shows this wasn't a woman to dwell on not getting credit for something that happened in the past. She was looking forward.
Definitely. And incidentally, we should mention that when she left King's College, Randall basically told her, "You cannot work on DNA anymore." So it's not like she just gave it up. I mean, she might have just given it up anyway, but she wasn't allowed to work on it officially.
She had to move on.
In 1956, she was diagnosed with ovarian cancer. There was cancer in her family history, but it also probably had a lot to do with her work with x-rays, during which she didn't ever wear a lead apron or anything to protect herself. And she often had to enter the radiation beam for extended periods to position specimens. So she just didn't realize at the time how harmful it would be.
How dangerous it was. And we've talked a little bit about that before.
Yeah, in the Radium Girls episode.
Exactly. So ironically, during the last years of Franklin's life, though, she became friends with Watson and Crick, even convalescing at Crick's home once after one of her cancer treatments. And according to that Wilson Quarterly article, Crick once said that they never discussed the subject of the race to find DNA structure. I mean, I don't know if
Which you're suspicious of.
I'm a little suspicious of that. I mean, I can imagine why it would be a taboo topic between these people. You don't really want to bring it up, perhaps.
Yeah, especially if you're trying to be friends. But
exactly. But I mean, I do wonder what they really talked about.
Yeah, and if she wanted to know how they got the information or anything like that, I guess
Yeah.
we'll never know. Franklin died at the age of 37 on April 16th, 1958, and there have been at least a couple of biographies written about her and a documentary done on her that was aired on PBS called The Secret of Photo 51. And there are also a couple of institutions that have named buildings after her, including King's College and Birkbeck College. And interestingly enough, King's is called the Franklin Wilkins Building. So she's kind of paired up with her bitter rival. Yes. So I don't know. I think a good thing to point out here is that by talking about Franklin, we're not trying to diminish any of the others' accomplishments. Obviously, we think Watson and Crick contributed a lot to this, and without their modeling know-how, they wouldn't have come up with DNA structure, and who knows what would have happened. I mean, everyone here deserves a little bit of credit, but I think that was kind of the point, is that there's enough recognition to go around.
Well, and DNA is such a huge discovery, such a huge accomplishment. There is plenty of room for 4 people.
Yes. And Watson did kind of relent on his earlier feelings about Franklin later. In his epilogue to his book, he did say, quote, "Since my initial impressions of her, both scientific and personal, as recorded in the early pages of this book," and of course we're referring to the double helix, "were often wrong, I want to say something here about her achievements. And then he says that he and Crick both came to appreciate her personal honesty and generosity, realizing years too late the struggles that the intelligent woman faces to be accepted by a scientific world, which often regards women as mere diversions from serious thinking.
I don't think we could put it any better than that.
Not at all.
Thank you so much for joining us on this Saturday. If you have heard an email address or a Facebook URL or something similar over the course of today's episode, since it is from the archive, that might be out of date now. You can email us at historypodcast@howstuffworks.com, and you can find us all over social media at Missed in History. And you can subscribe to our show on Apple Podcasts, Google Podcasts, the iHeartRadio app, and wherever else you listen to podcasts. Stuff You Missed in History Class is a production of iHeartRadio's How Stuff Works. For more podcasts from iHeartRadio, visit the iHeartRadio app, Apple Podcasts, or wherever you listen to your favorite shows.